Is it going? Okay. Okay, so my problem is 4.6, number 20, filling a trough. It says a trough is 15 feet long and 4 feet across the top as shown in the figure. The ends are isosceles triangles with a height of 3 feet. Water runs into the trough at the rate of 2.5 feet cubed per minute. How fast is the water level rising when it is 2 feet deep? So that's the X here, 2 feet deep. Okay, so first we have to write what we seek and what we know. So here we know already that dV dt, the volume, which was given to us here, the rate of change of the volume is 2.5 feet cubed per minute. And that's going to come in handy later. So, then we have to find out what we... I spelled seek wrong. Okay, what we seek. We seek dx dt, because I labeled that as x, dx dt when x equals 2 feet. Okay, so we are going to do from the volume. So the volume formula is 1/2 the length times the base times the height for the trough. And so 1/2, and then the length is, we already know, is 15. That's constant. That's not changing. So 1/2 times 15, and then the base times the height, which in this case is going to be x, times x. So now we have a problem, because we have two variables. What are we going to do? So we notice here that we have similar triangles. Here's one, here's two. So that is important, because we can do b is to x as 4 is to 3. And so we cross multiply. 3b equals 4x. And we're looking for x, because that's our feet. So we're going to put it in terms of x. So we're not looking for b, Jenny.
Yeah, you were solving for b right there.
I know, but okay, never mind. We're looking for b. So b equals 4/3 x. So we're going to plug that in for b over here, like Jenny said. 1/2 times 15 times 4/3 x squared, because we multiplied those two x's. Then, since we did that, we can derive. So dv dt equals 15 over 2. We're doing a product rule. Just combine those two terms. So the first times the derivative of the second. So over 3x dx dt plus the second times the derivative of the first, which is 0, because it's a number. And then we know that, since from our know up here, we know that dV dt is 2.5 feet cubed per minute, so we plug that in. And then we plug in the rest of what we know, and since we're looking for dx dt, that's what we're going to be solving for. This side makes it easy, because that just turns into 0, because it's times 0. We learned that in like 2nd grade. And then x, we want when x equals 2. So it's going to be 15 over 2 times 8 over 3 times 2 dx dt. And we're solving for dx dt, so when we do all that mathy fraction love stuff, we get 240 over 6 times dx dt equals 2.5 feet cubed per minute. Then you do some math that you learned in 5th grade, kind of, I think. And that is 40. It's a nice fraction, equals 40. And then so it's going to end up being 2.5 divided by 40 equals dx dt. And that simplifies to 1/16 feet per minute, which is dx dt when x equals 2 feet. Ta-da!